ellipses. Okay, today I want to continue writing the equation of an ellipse. Again, I just have two examples on your note sheet, and we're using this chart that we started on Tuesday as well. So again, you have your two separate types of standard form. Okay, in this one, we have x minus h squared over a squared. In this one is y minus k squared over a squared. Okay, that's your difference, is where your a and b values go in those two equations. Okay, your a squared value is always going to be your larger value. Okay, then we have our orientation. So this one would be horizontal, this one is vertical. And then we can find our different points on our ellipse. So we have our foci point, our vertices, and our co-vertices. Okay, so if we're given vertices and co-vertices, we can find our center point, which is h and k. Okay, I need h and k in order to write out the standard form of this equation. I also need a and b. So with example 1, we want to write an equation for an ellipse with vertices at -6, -2, and 4, -2. And co-vertices at -1, -4, and -1, 0. So when I look at this type of problem, what I want to pick out are my x values the same or my y values the same. Okay, in this case with my vertices, my y's are the same. Okay, so that means our k is staying the same between our two vertices. That would be this one right here, since it stays at -2 for my vertice. That means my form will be horizontal. Okay, so this one is horizontal. Okay, then going through our steps, we need first, to find the center. Okay, just like with our circles, our first step was to find the center. Same thing for an ellipse. We need to find the center. So if I have these two vertices, to find the center, I'm going to use the midpoint formula. Okay, so I'm going to use that midpoint formula with my two vertices. You could do the same thing with your co-vertices, but since I'm working with my vertices already, I'm just going to use those. Okay, so my center, I'm going to add together my two x values. So I have -6 plus 4 over 2. And I have -2 plus -2 over 2. Okay, so my two x's averaged, my two y's averaged. Okay, so I have -6 plus 4 is -2. -2 plus -2 is -4. So I'll end up with -1, -2. Okay, I'm finding the center first. So I have my h and k value. Okay, now in order to write my equation in standard form, I still need a and b. So step 2 is find a. Now to find a, if I look back up here at my chart, since I'm working with horizontal ellipses, I'm going to look for A. Okay, that has to do with my vertices. So I'm going to take one of my vertices. We'll just use this one. Okay, this value, my x value right here, has to be h plus A or h minus A. Okay, so I'm going to take this -6 I have to add on A. Oh, I lied. This is equal to, getting ahead of myself, it's equal to. -6 will be equal to our A value plus our H value, which we just found, is -1.
So -6 equals A. What is that next one?
Plus -1. Quiet, please. Okay, I need to add 1 to both sides. Now, for our A and B values, these are always going to be positive. So you're going to have the absolute value of A. So we're going to take the absolute value of -5.
Which is 5.
So A will equal 5. Okay, next step.
Then all you need to find is A and
We need to find B. Okay, next step we want to find B. So again, if I look at my chart, I'm going to go back down. If I look at my chart, since I'm looking at a horizontal ellipse, my B value would be here. Okay, that's in your co-vertices. Okay, one of my co-vertices is right here. That's -1, -4. Well, B has to do with that Y piece. Okay, so I can set -4 equal to our K value plus our B value. Okay, so I can set -4 equal to our K value we found is -2 plus our B value. Add 2. Okay, again,
B equals all.
I need to take the absolute value, both sides. Your A and B values, again, always have to be positive. So B will be 2.
Wait, these always have to be positive?
A and B always have to be positive. H and K can be negative or positive. Okay, so now that I have my center point, H and K, I have A and I have B, I can plug all of that into standard form. Okay, so last step, step 4, is to write out that equation. Okay, so I'm going to have x minus our h value is -1. That's squared. Over our a value was 5 squared. Plus y minus our k value was -2 squared. Over our b value was 2. That's squared, and that's equal to 1.
Walk a little bit, please.
This way?
Yeah, you want to go back?
Okay, I can rewrite this since I have minus and negative. I can rewrite that as x plus 1 squared. I can square this 5 to be 25. Plus, again, I have minus and negative here, so you can change that to a positive. 2 squared is 4. And again, it's always equal to 1. Okay, so before you start these steps, you will need to decide whether it is horizontal or vertical. So you need to look at your vertices or your co-vertices to see if your x's stay the same or if your y's stay the same. Any questions on our first example?
I'm
Yes.
almost done.
If your y's are the same in your vertices here, okay, that means if I check up here and I look under vertices, I know, I'm sorry. If you look under vertices right here, your k is going to stay the same. You're not adding or subtracting anything to it. So since it stays the same for both, that means it has to be horizontal. Okay? If you look over here at this vertice, you're changing that y value because you're adding or subtracting a. So this one would not be vertical since it's staying the same the entire time.
So the first two are different?
If your x values are different, it's going to be horizontal for your vertices. If your x values were the same, that means it would be a vertical ellipse.
Is it X and Y?
What do you mean?
You said the both the Y's were the same.
Yeah.
You just said the X and Y.
If the x's are the same, then it's a vertical ellipse.
Oh.
If the y's are the same, then it's a horizontal ellipse. Are we good? Can I go on to the next example?
Hold on. Oh, would you come sweat my Kennedy? Pretty good.
All right. Last example here. A listener is standing in an elliptical room that is 150 feet wide and 320 feet long. When a speaker stands at one focus and whispers, the best place for the listener to stand is at the other focus. Write an equation to model this ellipse, assuming the major axis is horizontal and the center is at the origin. Okay, so this length and width has to do with your major axis and your minor axis. Okay? Now, in this problem, we're also given this is a horizontal ellipse. So we don't need to figure out which direction it is. It already gave us that it is horizontal. Okay? They also gave us the center is at the origin. Okay, so your center is at 0, 0, since it's at the origin. That's your H and K. Okay, so I found the center. Next I need to find A and B. Okay, so to find A, you're going to take your major axis, since that's what we were given, and divide it by 2. Okay, your major axis is going to be your longest line. Okay, so this 320 feet is your major axis. Okay, we're going to divide that by 2. Okay, that is your A value. Stop it. B is your minor axis, divided by 2. Okay, so our minor axis is going to be the shorter. So that's 150 divided by 2. That's 75. And that's B. Okay, so this was our step 1. Step 2. And step 3. Okay, so step 1 was find the center. That gave you the center. Step 2 is find A. We found A using our major axis. Step 3, find B, use your minor axis. Okay, then last step is step 4. That's to write out your equation. Well, since it is horizontal, they gave us that, we're in this form, x, move up a little here, minus h was 0, over our a value squared, plus y minus k squared, over our b value squared is equal to 1. Okay, so I can rewrite this whenever I have an x minus 0 or y minus 0 and it's squared, we can just rewrite that as x squared over, I want to square 160. That is 25,600. Okay, then we have plus. Again, we have y minus 0. So that can just be changed to y squared. And we have 75 squared is 5,625. And that will be equal to 1. Okay, and again, all your ellipses are equal to 1 in their equation. Okay, so it should always be equal to 1. Okay, so if you don't have the center point, you need to use the midpoint to find it between either your co-vertices or your vertices. Okay, and then you want to find A, so you can either use the major axis if they give you that, or use your chart from the front. Okay, depending upon if it's horizontal or vertical, you'd find A by your vertices. Okay, plug in your K value found from finding your center or your H value, and then solve for A. Then same thing for B, and then you can write out your standard form of that equation. Okay, any questions on this one right here?
Homework, these are homework.